and then we start.
Path, if you are here, just give me a reminder if I'm going too slow. Okay, I don't want your part to be curtailed because I'm going slow. Okay, yeah.
Okay, so let's start now. Welcome everyone to today's webinar on OSDAG. This is an open source tree structure design software. We are organizing this webinar with Institute of Engineers India South Gujarat Local Center under the aegis of Mechanical Engineering Division. And I formally welcome all the participants to this webinar. Uh, Introduction about myself. I'm Himanshu Bhatt. I'm a secretary at Institute of Engineers South Gujarat Local Center. I'm also a partner at Maxell Designs LLP. This is a startup where we are exploring and implementing open source tools for mechanical engineering and helping others to take benefits through Maxell OSS. This is a Maxell open source software implementation category that we are working on. QR code is for my LinkedIn profile. If anyone wants to know more about me and wants to connect, we can connect over there. So, coming to this, our today's webinar, I would like to take you through first what is open source. So, generally, we think that open source means a free software. No, but then free has different meanings like free as speech or free as beer, or so that is the difference between an open source software when we talk about it. It is a public code for collaborative development. I'll give you some example also to understand this better what is free as speech and free as beer. So we'll not go into much history, but this just to explain that open source is not something new. The development of open source tools and softwares have a very long history, and many of the tools have reached to a mature and reliable stage by now. So, open source software, by its meaning, it is a source code is available publicly. So, anyone can study, modify, and redistribute it under specific licenses. The examples are Linux operating system. Many of us would be knowing that Python is a programming language which nowadays are getting very much popularity. Firefox browser, Postgre database, FreeCAD software, which we have already done one webinar on that. So if we talk about an engineering analogy, a proprietary software is like a sealed machine. Even if someone gives you it free, you cannot do any modification or any other alterations to the machine other than what its expected outcome is. Whereas when it is coming to open source, you can correlate it with a machine that comes with all the drawings and all the operational manuals, all the maintenance manuals. So you can just open the machine, repair it, modify the way you want. So that is how open source means. It is a source code availability, and the benefit is not only free software, but the modification of the software and ownership of the software at our requirement. That is the main benefit. So there are different licensing terminologies in open source, but as a user, we don't need to worry much on this because we can just use it for our requirement. But if we are into development category, then obviously we need to study this better. So the question is, are the open source reliable? As we started with, it has a very long history of development, and today, all our mobiles on Android software, it is nothing but a Linux-based version which is open source. You can see some statistics here. Around 96% all are in this range. So all the public cloud workspaces like AWS, Google Cloud, and the top 1 million web servers of the world, those are directly running on open source tools like Linux and all. So this is the power of open source, that it works at a mass level also. This is a slide presentation from Linux website. I'm not going into detail, but just to prove the statistics that the software in open source category are already at very mature stage. Dr. APJ Abdul Kalam, in his 2010 speech, Vision for Free Software Movement, highlighted the importance of open source movement. But if this is the power of open source, why we struggle with open source? The reasons which we could feel are limited awareness, where many capable tools remain underutilized due to lack of visibility. Learning curve. The initial setup and workflow understanding takes time because all of us, majority of us comes from Windows background. The open source majority works on Linux background. Now there are developments and things are coming up for Windows, but primarily it remains on Linux background. And support is not centralized because there is no commercial software, there is no seller. You don't have 24 by 7 support line. We rely on community forums, discussions, and self exploration. So these are few of the reasons why open source is struggling for its actual visibility in the engineering field. So we are here today to break those constraints and reap the benefits of open source. For this, on today's webinar, we have with us Professor Siddharth Ghosh, Professor of Department of Civil Engineering at IIT Bombay. He is PhD from the University of Michigan. He has held several academic and administrative positions at various categories. He is active member of several Bureau of Indian Standards committees related to steel structures, structural safety, spatial structures, and he serves as the convener of BIS committee developing the Indian standards on tensional memory structures. He also leads the IIT Bombay team behind the OSDAG, this software which we are going to discuss today. So he is the main person, and I welcome Professor Siddharth Ghosh to this webinar and thank him for accepting our invitation and helping us to spread the awareness about open source tools. With him, we are also connected with Mr. Parth Karya. He is project research associate working on the development of OSDAG. He is a structural engineer with core focus on steel structures with experience of around 3 years in the industry prior to working on OSDAG. And now for past 2 years, he is working on development of different modules and new user interfaces for this software. So we welcome both of you, and I hand over today's webinar now to the team of IIT Bombay to take us forward and explain us about the softwares in detail. Thank you.
Thank you, Mr. Bhatt. This was a very good introduction and very helpful as well. Before we begin, I would like to thank the Institution of Engineers, the South Gujarat local chapter, and Mr. Bhatt and others who are present here for the invitation for us to be able to, spread the awareness of open source software. Whatever little we can do, we are trying to reach out to everybody so that you get to know about what we are doing and also how it can benefit your own individual work on a daily basis. And Mr. Bhatt's presentation on open source software is going to help me a lot in this presentation. It sets up a platform. It sets up a foundational understanding of what open source software is. And today, what we are going to talk to is open source software. And I know that many of you may not be very familiar with what we are going to talk about. It's not so crucial that you need to understand everything about this, but this might be a very, new beginning for you as well. Okay, so considering the time that we have, we'll start with the presentation. I would request you to put all your questions and whatever queries you have on the chat box so that we can collect it and later on If we have time today, or if we don't have time today, later on we can definitely try to get back to you via email. So that would be my request. Um, just hold on to your questions and definitely put it on the chat box so that we can get back to you. Okay. Without much introduction, I'll start my talk here, and we'll try to respect the time given to us and also respect the platform given to us, and try to connect to you. I'm assuming that many of you are in the domain of structural engineering. Many of you are practicing engineers, although I understand that there are some students who are also interested in things like this. And also there may be some teachers. This talk will be oriented towards everybody, but more towards whoever is enthusiastic about designing structural steel. So the other thing that I want to say before we go ahead is that, many a times what we see in the structural engineering domain is that most of us practitioners, we don't feel so confident about structural steel design. And whenever there is a challenge, whenever there is a task given to us, we resort to solving it with reinforced concrete structures. So we thought that why don't we help our community by developing something where designing with structural steel becomes easier, and it doesn't become a burden, doesn't become a big constraint that you want to do. And that's one motivation why we went for an open source software instead of the typical software that we use here. So this is how today's talk would be structured. You can look at the QR code to know more about OSDAG, which is a short form of Open Steel Design and Graphics. And you can see our logo. By the time we end this talk, I'm sure this logo will be familiar with you, familiar to you. And the link for our LinkedIn page is also over there, where we keep on posting all the new features, new modules that we have on our software. And like we said, it's freely available to everybody. So it's good to be able to connect. Anyway, this whole presentation will be available to you after we close. So don't worry, even if you cannot capture the QR code right now. So we'll start with the basic introduction to our software. So let's talk first about what is structural design software. I mean, what do we expect out of a modern structural design software? I know many of you, if not all of you, must be using some structural design software. I know, my engineering colleagues use StatPro, ETABS for design. Some people use SAP 2000 for analysis, and there are many others. I mean, it is definitely not a big list, but we do use them on a daily basis. We also use finite element software for analysis, like Abacus, ANSYS, etc. Uh, with that background, let's just take a moment and try to think about what do we want to do with this. Okay, and let's focus not on the analysis but on the design part, because we know design is a task that you are given often, and design not a simple task. Design has sort of the individual artistic or subjective input built into it. It's not that there is a algebraic equation and you have to find what's the value of x. No, it's not that simple. So what do you want from a structural design software? Obviously, the most important thing would be that it accurately interprets the design standards. IS 456, IS 800, which one you talk about, or any other code. Okay. Also, you want to know if the design calculations are proper, and you want to see, you want to check them. So many a times when you use a software, we want to go through the design calculation in detail and make sure that yes, what we know as design process has been properly implemented in the software. That's why we don't trust every software to the same level, right? Because we know our engineering, we know our design. So you want to do it that way. The other important aspect is that in the whole process of design and construction of a structure, it's not only the structural engineer who is involved, right? So there is also the architect, the planner. After you do the design, there is the contractor who will take care of the construction, etc. Now, what we need is that there should be a smooth collaboration among all these different parties who are part of this whole exercise. And we want this collaboration to happen through the software as well, as much as possible. So if the architect gives me a drawing, which I cannot easily put in my structural design or structural analysis software, then it takes more time. Time means money, and we don't like that kind of a workflow. So what you're looking for is an automated design workflow. This is a very key to today's software development, particularly in the domain of structural engineering and construction. You have to have that. You have to have sort of interoperability also. So I need the drawings from the jobs person that I can easily give it to my structural design or analysis software, and finally it could be taken to another software which can be used in the field to check if there are conflicts between two members, etc. And you all are familiar with this. You are just going through a recap of what you need. Of course, it has to be easy to learn and use. And if you look at today, what we always want is our design should be optimized as much as possible. We can't avoid that. You can't keep on using resources as much as you want. There is always a constraint. We talk about net zero. We talk about circular economy. So optimization is very, very important. And then if I get more and more experience with the software, I would also like to, change the software a little bit, tweak the software a little bit, so that it becomes easier for me to use the software. So that's where customizability comes, and that's where the extensibility also comes. I know many of you may be, you may be writing an API for your software that, okay, I get the output this way, but I want it in a different way. So I write an API. Maybe you'll be using tools like you'll be writing macros using Microsoft Excel. So these are things we want to do, and this is what we want our software to be able to provide that facility, right? And finally, with all these constraints, we can't build a software that nobody can afford to purchase, right? So it should be affordable to everybody who is using it on their daily stuff. So considering these things, we are trying to create our software and keeping these things as sort of, I would not say hard constraints, but very, very important requirements. Okay. And I'll not go through what we do over here, but you'll see things like IFC based workflows. I'm quite sure that most of you are familiar with what IFC is, how you can import and export CAD options. Do I have a simple graphical user interface, GUI or not? But most importantly, after we go through all of that, what we want to focus on that, considering everything, why do you go for an open source software? Why do you go for a free software? Again, open source and free software, as Mr. Bhatt was telling you, have the abilities to provide you a solution for all of these. Open source means transparency. So if you're looking at transparency, of course you should go for open source. If you're looking for affordability, of course you should go for open source. So these are the basic considerations which finally tell us that our free and open source software becomes our only target when we're trying to give something to the public and make them more enthusiastic about structural steel design. So what we are trying to do, currently what we have are black box software, where it's a black box because you don't know what's happening inside, right? So to develop a faith, to develop trust on this software, you need to keep on using, do cross checks, many ways for years to develop faith. Still, sometimes you may say that, oh, I don't really know how this mass is calculated. I don't really know how torsion rigidity is calculated. Things like that. That's where the open source, the free and open source or FOSS software comes and says that, oh, I can tell you what it does exactly, and you can make sure for yourself that it does it the way you want it. So absolute transparency is something that you can achieve through that. Now coming to OSDAG, what does OSDAG do? Okay, so it's a very simple software. That's why sometimes we call it a tool, not even a software. And it does design and detailing of steel structures as per IS 800 2007, because that's the most recent code we have. Once we have it updated, we'll go for an updated version. So note that it follows IS 800 primarily to its core, and the goal is to have to aid teaching learning in a classroom environment for structural steel design, but also for practicing professional. You wanted to provide an affordable and a very transparent alternative to typical software that you may be familiar of doing some kind of work on, right? You have heard about FOSSI. Many of you might know that this whole series, there have been many such demonstrations of other free and open source software. And these are all created under the big umbrella project called FOSSI. OSDAG is a part of this, and we are funded by Government of India through its NME ICT mission. Now, what are the motivations? I touched upon this earlier, but let's go through it again. What we find, and I find, I would say it's my personal experience, but this has been corroborated by many experts in this domain, that many structural engineers are not really confident in steel design when we compare them their expertise with RC design. It's a very big difference. In most places, if you go, only a few people know how to do steel design. Most others do not. It's an unfortunate situation, but this is one big motivation for creating OSTAG. Also, there is a lack of standardized and accessible tools for teaching and practice. So when you say standardize, we are looking at Indian standard, of course, but also how you practice it, okay? And accessible, so affordability becomes a constraint. Commercial software that you have are costly. For example, OSTEC focuses a lot on connection design, and whoever is doing steel connection design, that software that provides you very customized solution on connection design are really, really costly. you know. Well, what we did in India, let's see, if we look at 20, 30 years back, there is still a lot of software piracy. So we used to have pirated software on our computers, which is definitely not an ethical thing to do, right? So we also wanted to move away from that. I mean, why with our technological know-how, why should we use pirated software and so on? On the other side, if you look at a typical design office, a typical consultant's office, you'll see that they are using some sort of in-house expertise. They create Excel sort of spreadsheet-based solutions, and this is handed down from senior to juniors. They learn, and these things happen. Now, what happens is that this is not a standardized solution, right? These solutions are developed for very niche domain, very specific problems, and it's not spread out. So unless I'm a part of that elite group of consultants, I don't have access to that. Okay, so there are these issues. And then the other thing is that many software um, just did one thing. For example, many software just do analysis, some just do design, and for detailing, you have to go for another software. I'm sure that all of you have heard of designing in SAP or ETABS, sorry, STAD or ETABS, and then doing detailing in RCDC on some similar software, right? This is also something that we wanted to handle last time. So what we want to achieve is something that we'll talk again later. So I'll skip and go past this. Let's see what OSDAG looks like, what it offers, right? So OSDAG, it's a free software. It provides you a nice GUI, and later on we'll talk about that. We are also developing a web version of it. It's still under development, but OSDAG is something that you can download and start using. This is how it looks. I'm sure the OSDAG logo is slowly getting familiar to you. So on the left side, you'll see different modules what we do. So we have connection module, tension members, compression module, flexion members. So they may not look very professional to you because when we started doing this, we thought more of it as a teaching learning thing, which you can actually learn in detail what steel design is. Because as you said, we found many people who don't know how to do steel design. So we thought that we start with the basics. Okay. And like any new commercial software, it works in a project mode, in the sense that if you are continually using it, all your recent projects will be highlighted to you with dates, etc., and you can quickly access a saved design report, or you can go back to the project by opening the project. We also are going to give options for plugins. We'll talk about plugins later. It's still under development, but it will be able to incorporate plugins in a very simple way. Also, if you use it in a significant manner, you can search through your projects. There are many other features that one can use. The moment you select one module to design, for example, here you're selecting tension member, Then it gives you the submodules. Here you have two kinds of submodules: tension members which are bolted to the end gusset, and tension member which is welded to the end gusset. So two different kind of truss members can be designed using this. So you can see here that here in the design of the tension member, we are also considering how the end connections are going to be, because that's very important. It's not just, you find the force, you divide it by the cross-sectional area, and if it works. No, it's not that. It's much more detailed compared to that. Similarly, if you go to flexure member, you will see different options like simply supported beam, etc. Now, once you select the submodule, it opens this window, which is a tab for a tension member, and you have selected the tension member bolted to the end gusset. So it opens like this. Using this, you can do a design, and I'll quickly introduce you to the different parts of it. To the left is the input dock. To the right is the output dock. So output dock right now is completely blank. It fills up when we have something designed. When we design, we'll also see a CAD model of the design on the CAD window. And below this, there is a log window, which will tell you how the design is going. Okay. So let's quickly look at what we see over here. To the left, you can define all the design requirements. For example, here you see what kind of section are you going to use. So you see angles. Once you say angles, it will show you how the angle will look like. Then it asks you how the angle is going to be connected to the gusset, using the long leg or with the short leg. You can specify that. You can specify many other ways. So these are all drop downs that one can use. Then you specify material, then you specify what is the length of the member, and what is the force demand. And then I'll come to each details later on. So you can see the options. This is how different sections that you can use to design the tension member, how you connect it, uh, the material, the forces, as you know. And then once you go to the bolt and in the diameter, you don't specify the bolt diameter. Uh, Either you could select all, that means all bolt diameters that are available typically in the market, or you can say that, my supplier gives me only this bolt, so I will use these diameters. So once you say customize bolt diameters, it gives you an option to select. Okay, and using this pop-up, you can select what bolt diameters you want to use for this design. So here you are selecting 8mm and 10mm bolts, right? Similarly, what kind of bolt behavior you are expecting. So you can use bearing bolts, which are the typical black bolts, or you can also use friction grip bolts or HSFG bolts, right? So that selection option is there. Similarly, for property class, which grade you want to use. Here, all are selected. So these are again as per our standards. You will see the whole standard has been coded into the software. So you have all of these on the tip of your mouse click, right? And the plate, which is basically the gusset plate, what kind of thickness you're going to use. Again, you can give individual selections, you can select them all, or it's up to you. So here you are selecting some discrete values like 14mm, 22 and 28. It will do the design with that. Once you have fed every information, and by the way, you can see that there are these asterisk marks. Wherever there is an asterisk, that means it's a mandatory information that you have to select. And once you do that, you need to click on this design button, and then it does the design. You can also separately save the input for future use. There is one more thing that I wanted to show you. So far we are talking about basic inputs, but there is this tab for additional inputs. So if you are an experienced designer, you can come to this, but for learning, you don't need to come to this. But for an experienced designer, yes, this is very important. Okay, so let's look at what it is. So we have selected HSFG bolts. Now in HSFG bolts, it says, do you want to have some pretension or not? What kind of bolt holes you want to have? Standard, oversized, slotted, these options are there. Then if you select the slip factor for the bolt, which depends on the friction, once you click that, as you can see to your right, it gives you the whole table for slip factors that IS 800 provides. So when you select a value, you can actually refer to this table and you pick whatever kind of pre-treatment of the plates you are using. Depending on that, you can select and go ahead for the design. Similarly, there are more detailed options that you can have on the angle section. You can look at the section, all its properties. You can look at the collector plate or the bolt, the detailing options that are there, and then other design options. And again, you can save this and click design. So once we click design, it undergoes the design process and finally comes out with something like this. We'll give a demo, so you'll be able to see what happens in that. And this is, CAD model created to the scale. You can see it shows the gusset plate. It also shows the bolt in dark rusty color. And there are controls for the CAD over here. You can zoom in, zoom out, pan, rotate, and this small cube also does many things. You can see over here in the log window, it says that the bolted tension member design is safe and end of design. It gives you a time-stamped design information. To the right side, you find all the information related to the design. Absolutely every information you can find over here. There is a scroll bar, you can scroll down, you can find information on the section, what are the capacities, what are the demand, what is the utilization ratio. Many times you look at that. And you can see it's, since you gave many options, like you can use any of these bolts, any of these plates, the utilization ratio is pretty high. You can achieve good design. Similarly, there is information on the bolt, the cassette plate, and so on. Here you can see if you don't like the design, you want to change something, there is this orange button that you can see. So if you want to change it, it doesn't let you change unless you intentionally want to unlock. So once you unlock, then you can change the design. Again, you can generate a design report. You can see the button here, and also save output is a spreadsheet readable CSV format. If you look at the CAD part, as you put your mouse on the CAD, it highlights wherever your mouse is, it highlights that component of design and tells you, gives you the details of that design. So it says it's 6.8 grade bolt, diameter is 8 millimeter, and the number of bolts in this connection is 2. Here also you can see the details, and it says what would be the spacing between bolts, what is the bolt capacity, all information. And if you remember steel design well, you know that there are many calculations, including long joint reduction factor, large grip reduction factor, etc. And this shows that it can take care of all of those, and it has taken care of everything. Of course, if you want to see whatever you have designed in greater detail, you can sort of close the input and output dock and fill the whole window with the CAD window. And here the whole model is selected, but you can also select the plate and the member and the connector separately. It will show it that way. Why we put this much effort into the CAD is that many a times what we see that very young professionals are not so familiar in terms of being able to visualize the thing that they are designing. So if you tell them directly, oh, this is a type 1 connection, the bolt should be here, they may miss out on that. But once they design something, they keep on seeing these things. What is a type 1 connection? What is a type 2 eccentric connection? These things would be very, very easy for them to understand. And that's what we try to achieve with this. So you see that the input dock and the output dock has been closed. This can be selected using these buttons over here. It says that these are closed. Again, if you click on this, the small arrow that you see there here, this part will get darker and you can see the whole thing. There will be a demo, of course, and you can see much better on what it does. We'll also see more about the cube, the zoom controls I talked about. And as I said, you can see it separately. Here we are looking just at the individual member, the angle section. This is a scale model. So if you have a cutting machine and you want to put, you want to drill holes for the bolts, you can actually give it to your fabricator, and they should be able to very accurately put the holes of proper dimension in the perfect location. That's the advantage. So we talked about interoperability, right? You get the information from the structural design and give it to the fabricator, and they can use it. And that's what we are trying to do over here. Once you click generate design report, it asks you who is creating this, for who they are creating it, and the profile of the designer, basic stuff that you get to see. And it also gives you options to mark which parts of the design calculations you want to see in the report or you want to put in the report. So you can select or unselect some of these. As you can see, the greens are the selections, others are are not selected. So you have those choices, and the design report comes like this, with all the the header has all the information, how you have created, who has created, on what date. This comes by default, and this is a PDF file which gets created just by one click. You don't have to write anything, it just comes out. And see to what extent we provide the details. So every row, if you see, the check is, let's take the first one. It checks the maximum pitch distance, right? And how what is the required value. It shows all the different calculation, and for thickness what is the calculation. It also marks you for which clause, from where we are getting these values, right? And what we have provided, it's here. So it says that, yeah, fine, it's passing. So this is how step by step for each calculation it will show that it's working fine. There are options to save the project. As you go to file, these are the very top level, high level options. You can save it as a project, you can save the log message separately, about creating design report. But what I want to draw your attention to is to how to save the 3D model. um, you can save the 3D model in different CAD formats. It gives you a pop-up, obviously, and you can see here the 3D model can be saved in different formats like IGS, STEP, STL, BREP, or IFC. So these are different formats where the CAD can be opened into any CAD software. I don't know what you are using. Maybe you are using SolidWorks. Maybe you are using FreeCAD, which is another free and open source software. So all these CAD apps or CAD software can open these files. I'd particularly draw your attention to IFC, because IFC Industry Foundation class is the standard for any BIM, building information modeling software, and it should be the key for interoperability between software. So information can go from one software to another software without any hassle at all. And here we are showing you that we got that IFC file, and we are looking at the IFC file using a BIM viewer software. And once you select, you can see the green one is the selected one. It shows to the right side in this box. You can see it shows all the necessary information for this element. Okay, it even says what code it is using and all the dimensions. Every information is given there, because that's what IFC does. It shows the metadata very easily, and one can check the design as well. This is again, these are different kind of element. This is beam to beam splice connection, and using bolts. There are flange splices, rear splices, everything, and the CAD is imported to FreeCAD here. Similarly, you can import it to AutoCAD also. And I mean, if you are familiar with this drafting software, from the 3D model, you can also create 2D drawings, structural, good for construction drawings that can also be created. So that's how we ensure that, okay, it goes very easily from the structural designer to someone who's going to check it using the design report, or someone who's going to fabricate it, and finally it gets constructed. Okay. We'll quickly go through some resources that we have, because that's also very, very important. So here is the most basic of our resources, the OSDAG website, and you can see the website is very easy to remember. It's osdag.fossee.in. Fossee, I said earlier, Fossee is the mother project, and OSDAG is a child here. Fossee is for, again, free and open source software for education purposes mostly. But as you can see, OSDAG, it can be used both for education and actual engineering practice. So if you go to our website, you get to see all the resources. You can download the software freely. You don't have to pay anything. You don't even have to register. You can just download and use. And there is forum for asking questions. All information are here, and of course you can contact us through that. That's the most important thing. So you can see our last release was in April for both Linux and Windows. You can download, and very simple to install. It doesn't take much time, and our requirement on the hardware is not very huge. It's quite simple. It works on Windows 10 and 11 and most Linux distribution. We have definitely tested in Ubuntu and some other Linux OSs flavors. Probably it can be used in other things as well. Um, like I said, there is a discussion forum where you can ask any question related to OSDAG. So this is something you can do. Once you start using it, you'll see how beneficial it can be. We also do have a YouTube channel and we have a LinkedIn page. With the LinkedIn page, you will get to, if you follow our LinkedIn page, you will get to know about our releases. But in addition to releases and announcement of, workshops and internships and other things, you will also sometimes get to see some very small video tutorials through which you can learn how to use OSDAC. So I would definitely recommend all of you to start following the OSDEC LinkedIn page where we keep on posting information. This is where we are most active. This is our basic social media page. Uh, like this, we conduct training programs. It's not always online. It's also sometimes in person. So you see, we go to colleges, we train students, we train professional engineers, uh, we train college teachers, all this. And this is something we have been doing for a long time. And this is something we want to keep doing because we want to reach out to people and make them start using this. So I'll stop over here and let Parth take the reign. I know you might have many questions. Please put on the chat box and we'll try to answer them later. Okay. Parth, I'm stopping to share. Uh, you can start.
Yes, thank you, sir. I'll share. Okay. Is the screen visible?
Yes, the screen is visible. You can get to full screen mode maybe.
Yeah.
Yes, perfect.
Okay. So, hi, thank you everyone for joining. I'll give a brief demo on OSDAG. So the first demonstration problems is on clit angle connection. How we have tried to frame these demonstration problems is like a textbook question where we'll show how we can integrate OSDAG. Okay, so this question says design a clit angle connection between MB400 and MB250 beams for a factored design shear force of 40 kilonewtons. The bearing bolts available are of size 12, 16 and 20 and of grades 4.6, 5.6, 8.8 and 10.9. And the grade of steel that the question is asking us to take is Fe410 with Fy 250, and we can assume any data if necessary. Okay, so now if I go to OSDAG, I hope the OSDAG screen should be visible. So as we discussed, this is the OSDAG homepage. This is the modules that we have. So since the question has asked us to design a clit angle connection, so we'll come to connection where we have a lot of different types of connection, and we'll go to shear connection, and there we'll find the clit angle connection module. Okay, so these are the inputs for the clit angle connection module that are required, and so now we'll again go back to the question and see what are the inputs. So the module that we have selected is we went to connection, shear connection, and clit angle connection, where the connection is between two beams, MB400 and MB250. Okay, so now here you have a few options, like you can connect the column flange and beam web, column web and beam web, and beam to beam connection. Since the question asks us to do a connection between beam and beam, so we'll select beam to beam, and you will see a representative image of this connection here. Now the question says that the primary beam is MB400, secondary beam is MB250, and the material is E250 Fe410WA. So we select the beam from here, MB400 and MB250. This list of beams is, we've tried to cover a lot of beams as per IS 808 and the commercially available NPB, UB, UC sections. This is a comprehensive list. However, if you want to add more, say, members to this list, there is always an option in additional inputs where you can download the sample file, put in the values, and import the file again, and you can add your members to the database as well. Coming back to the question, shear force is of 40 kilonewton and bolt diameter, which are say available, are 12, 16, and 20 mm. So I'll input of an shear force of 40 kilonewton, and diameter I'll go to customized. Okay, and I'll move the selected ones all to the left, and then I'll select 12. Then I can also select and use this arrow 16, and I can double click 20, and then I can press submit. Okay. The type of bolt is bearing bolts, and the property classes 4.6, 5.6, 8.8, and 10.9. So now again, property class, I'll go to customized. I'll again move all of this here, 4.6, 5.6, 8.8, and 10.9, and I'll press submit. We have already selected bearing bolts here, so we don't have to change that. And now which angle that we are going to use for this connection, the split angle. So the question doesn't specify that. So here, what we can do is we can select all equal angles as per IS 808. So I'll just go for all. Okay. So these here I have given all of my basic inputs, and now I'll just press design. So now the design is done, as you can see. Here you see the CAD window, the output dock which got populated with values after the design is complete, and the log window which says the end of design. Okay. Now coming to the CAD window, we can go and hover over this, and it will give us the labels, which are the members, which is the primary beam, which is the secondary beam. Then it will go to the angle, which is the angle selected, details of the bolts. Now we can use the scroll wheel to zoom in, zoom out. We can also use these buttons to scroll in and scroll out. We can click and rotate, and we can press the scroll wheel to pan. Similar functions are available with the cube as well. You can the user can select different views here and can view the CAD from different angles. Then you can rotate with these arrows, and this is how we can rotate as well. So this is how the entire CAD functionality looks like. And as discussed in the features section, we can separate out different members and examine them and also export them for detailing. Now coming to the output dock. In the output dock, we can see different outputs, which is the selected designation, and this is the most optimum designation as per the calculation. That's how the algorithm has been set. And then we'll see different values of the shear capacities, the selected bolt and diameter. Like we gave OSDAG few options like select between 12, 16, and 20, and 4.6, 5.6, 8.8, and 10, 8.8 and 10.9. So based on that, it went for an optimized design where it has selected 12 and 12 mm diameter with 4.6 grade. Then it will also show spacing details, which is how the bolt has to be placed, and the capacities. It will show the capacities here. And the most interesting part is it will show different failure modes as per the block shear patterns. So this is about clit angle connection, and if I unlock this from here, then the outputs go away, the cat goes away, and you can do a fresh design again. Now from here, how you can go to the home page again is you can just hover over the sidebar and you will see all the modules. You can also jump to other modules from here. So we press home and we see what's the next question. Okay. So here the question is, design a bolted splice connection for LB 400 beam for a factored shear force of 75 kilonewton and a factored bending moment of 45 kilonewton meters. Design the most optimum connection using friction grip bolt having flange splice plates only on the outside. Take FE490 with FY350. Assume coefficient of friction as 0.48 and other data if necessary. So now, when we go back to OSDAG, and again it's a connection, but now we have a moment connection and it's a beam splice. So we went to connection, moment connection, beam splice, and cover plate bolted. Now in cover plate bolted, the question suggests that the designation of the beam is LB400. The material is E350 FE490. So we go and select LB400 and we have the grade selected as E350 FE490. Now the load demands are 75 kilonewton and of shear force and 45 kilonewton meter of bending moment. So shear force of 75 kilonewton and 45 kilonewton meters of bending moment. The flange splice preference is outside. The type of bolt is friction grip bolt. So the flange splice preference, it's outside. We also have an option where the flange splices can provided on the inside and outside both. And now we are going for a friction grip bolt. And the question says that design a bolted splice plate connection. So it doesn't give any details related to bolt diameter, bolt grade. So here we will select all. It also doesn't give any detail related to the available thicknesses for flange splice plate and web splice plate. So here too we'll go for all. And now the question says that 0.48 is the coefficient of friction that we have to use. So we can go to additional inputs and slip factor. We can come here and define and press save. And now we can press design. Within few minutes, few seconds, this design is completed, and you can see the CAD window and the output dock. So now I'll move to other features like Save 3D Model. So we go to File and we select Save 3D Model. And we'll have options where we can save it as .brep, .iges, .stp, .stl, and .ifc. Once it's taking a bit to load. So once this CAD saving option comes, we can show how it is saved as an IFC, and any IFC file can be opened in a BIM software such as Revit. Currently, we are using BIM Vision. So you can see that this drawing has been exported to BIM Vision, where we can select and see all the details of the members. We can select the bolts, the nuts, and we will get all the details. So this can be effectively used in BIM workflows to calculate quantities, to calculate bill of quantities, and to do for estimation, etc. Yeah, so here once save 3D model is pressed, we have these 5 options, which is IGS, STP, STL, BREP, and IFC. We have seen how we can save it as IFC and then we can view it. Typical file format for AutoCAD and related softwares is IGS, which you can use with AutoCAD and Revit. Now we can go and generate design report. Here we can give in basic details of the project, company, project title, etc. And then this is not a compulsory input, but this is required for many professionals submitting their designs. And then we press next. Now here we can select the sections that we want to print, and then we can either do preview PDF or save PDF. So once we do this, any any design report would look something like this. So here this design report starts with the input parameters, all the inputs that we have given. Then it will give us the design status upfront, like has the design passed or has it failed. Then it will go into all detailed calculations with the clause numbers as per IS 800, and it will also give some comments like say this is limited to low shear, etc. So this is the design report where also different interaction ratios are being calculated. And the design report ends with the views of the CAD saved as 2D. So this is the entire design report. Now yes, I'll move to the next question. This question is a design a 6000 long plate girder with thick web for factored shear force of 60 kilonewton and a factored bending moment of 125 kilonewton meter. It is a simply supported plate girder with both flanges fully restrained. Take Fe 490 grade steel with Fy 350. Assume a bearing length of 150 and other data if necessary. Okay, so now we'll go to the module flexural members plate girder. So again from here we can go to flexural members directly, and here we can open plate girder. Now, plate girder requires a lot of inputs, like what is the size, width, etc., based on the load requirement. So, plate girder is one module where we have integrated, which is an example of how research and practice can come together, where we have integrated an advanced optimization technique, where based on the load inputs, it will optimize the girder dimensions and give you the most optimum design. This is done using particle swarm optimization, and we'll try and give you a brief demo of that. So we are designing for E350. Design type is optimized, and we'll since it is optimized, we'll just not touch all of these, but we can also set bounds like the depth can be between 200 and 1000 2000 with an increment of 25 each. So we can define these bounds, but we'll go with default bounds at the moment. And the shear force is 60 kilonewtons, the bending moment is 125 kilonewton meters, and the length is 6000 So the length is 6000 bending moment is 125 kilonewton meters, and shear force is 60 kilonewton. So bending moment is 125 and shear force is 60. What are the other inputs which are necessary is bearing length is 150 major laterally supported. It's a thick web plate girder, so thick web without intermediate transverse stiffeners. So we'll go and select major laterally supported, bearing length of 150 It's a thick web without ITS. Then warping restraint, both flanges are fully restrained. So warping restraint, both flanges are fully restrained. Now depth, flange width, flange thicknesses, and web thicknesses. As mentioned, we are going for an optimized design. So we'll let the software, let OSDAG optimize this and give you the design. So we'll just press design. So this is the optimization visualization window where one can see the plate girder getting optimized based on dimensions here. This is the graph which shows the utilization ratio greater than 1, which are the failed members. The members that have passed, you can see on this side of the screen, this grayish screen, and this star, if you see, is the most optimum design. So the iterations here, you can see it is iterating. Each iteration has 50 particles. So currently OSDAG does around 100 iterations multiplied by 50. So around 5,000 iterations, 5,000 samples of design. This we have come after doing some sort of back and forth on how we can optimize and how we can get reliable results. And we have recently also included this in OSDAG Bridge, and we'll discuss about that. So once the iterations are done, we get the most optimum design. This is since it's a simply supported plate girder, you can see the supports. And there are, since it's thick web, there are no intermediate transverse stiffeners, but there are longitudinal stiffeners at the end, bearing stiffeners. Uh, that's it for the demo part. Yeah, so I'll just give the concluding remarks. This is our current team led by Professor Siddhartha Ghosh, and this is the team sort of that works on the overall vision of OSDAG, but the entire development of OSDAG is being done by a lot of interns. And as we speak, there are close to 40 interns who are working at the moment who work on continuous development of OSDAG. These are our experts, and each and every design or DDCL gets reviewed by the experts, and then we sort of do the design. I'll just go through this quickly since we are ending the time. So this is our module development process, and these are our available modules. A lot of modules in connections, close to 15, and other modules like base plates, tension members, compression members, and flexural members. Something that is currently under development is compression members and flexural members, but something that will be out pretty soon is our plugins, which is OSDAG Bridge. What are we working on next is this is how OSDAG on web looks like. Currently, you have to install OSDAG and run it, but eventually you will be able to run it through web, and you do not have to install anything. And the interesting part about this would be that it will have a responsive UI, so you will be able to do this on your phones, on your tablets, anywhere, and you will be able to design it on site, share the reports, share drawings, etc. We are working on a comprehensive plugin framework where we are developing our plugins, but we also want other contributors to develop plugin, and you can then share these plugins with us, and we can integrate it as official OSDAG plugins. So this is also something that will be out in the next release. This is the OSDAG Bridge plugin, and I'll just spare a couple of minutes here that this is a plugin that will be out very soon, where there are very basic inputs that are required here, and you will be able to do a comprehensive bridge design, analyze it, design, optimize, and detailing. All four things within a few minutes. You will also be able to export this design as an IFC file, as an IGS file, like all capabilities of OSDAG. Plus, this will also be a very effective enhancement tool or teaching tool, because you will see, and once you experience, all of these drawings are very dynamic. Like if you go and select no crash barrier here or no railings here, these drawings will get automatically get updated, and these again include the relevant IRC standards. This is another tool which we are working on, and which will also be available as a plugin and will be out soon, is the life cycle cost assessment tool, which will be for bridges like the OSDAG. The bridges that you design in OSDAG bridge, you can do a full life cycle cost assessment of these bridges with this software or this plugin. Uh, what's next for OSDAC per se is, since we have introduced the analysis capabilities for bridge design, we'll include this now and bring them into OSDAC for truss and truss connections and other beam column modules. What we also are intended or working on is textbook companions, like standard steel design textbooks, where each and every question you can solve it on OSDAC, and we can make this available to everyone, so it helps in teaching and aiding. And we are also interested in or say working on developing user manuals and developers manual. Plus we are doing more engagement, doing more online programs, offline programs, etc. You can collaborate with us. If you are a faculty partner, you can collaborate with us to integrate OSDAG into your teaching curriculum. Industry partners can contribute into development of custom modules, or we can train your workforce in OSDAG. Individual developers, you can contribute to develop module development to any small or big part of OSDAG, where we have now sufficient documentation that can help you contribute effectively. For students who are here, we do a lot of internships. We take close to we do around 100 plus internships a year, because that is our main workforce who do the development. So if you are interested, currently there is no call for internships out, but one will be out soon in say August, by August. So you can stay tuned to our LinkedIn page and apply for internships. I think with this, I'll conclude. I'll thank IEI, and also our acknowledgement to all the sponsors who have helped in developing OSDAC. Thank you.
Yes, thank you, Parth, for this wonderful live demonstration showing the capabilities, features, and particularly the optimization features which we are seeing on the live screen. There were many reactions and people applauding that. So wonderful session. Thank you for this. We have a few questions we'll quickly take because time is running off. But on questions pen, I can see one question is, can this software create bar bending schedule, BBS?
Parth, should you go ahead or should I answer this?
No, I can. So bar bending schedules, no, because our focus is again on steel structures here. So no, we can't use for bar bending schedules.
Another question is, does it cover hollow, squared, rectangular, tubular sections?
Not for connection design, but for column design and for base plate design, we do cover tubular sections, hollow sections.
Yes. Okay. Another one is for multiple input material grades and sizes. Will the software consider the most optimized case with maximum utilization ratio? I think the answer is yes, because we already seen that, right?
Yes.
Detailed calculation report with applicable checks. Yes, that also we have seen all the detailed calculation report with code compliance equations are generated. Next question. In the future, cold formed member and its connection design possible?
Not in the immediate future, but eventually maybe.
Okay. Does OSDAG support Eurocode 3 EN1993 for steel design?
No, we just support IS 800 at the moment,
I said
Indian
it,
standard
yes.
codes.
Are we dome full scale? I don't understand. Okay, are we dome? I think the question is not clear, but maybe they are asking whether we can do some dome design for with steel structure in this
So we
software.
can design different members like tension members, compression members, but we can't analyze it at the moment. We can't analyze using all that at the moment.
Perfect. So these were questions on the question
I
pen.
just want to
We
add
have
one thing. So basically, OSTEC is a design software, and it doesn't do analysis at its current stage because it's focusing on individual component design. And the next phase for OSDAG is to do systems design. For example, to do design of a truss, a frame, or a complete floor. And there, of course, we'll have to include the analysis features, including the results of analysis in the form of bending moment diagram, shear force diagram, deflection diagram. In fact, we went for the OSDAG bridge design, and OSDAG bridge already includes all of these features because it's a system design, and the analysis part is very important there. And soon it will be there for other OSDAG the system component as well.
Uh, Fine, sir. I'm seeing many more questions in the chat box, but due to time constraint, we'll not be able to take up all those. So I request all the participants to send your queries to our email address on FOSSI website also, and the screen on screen it was shared. So you can share your questions, and definitely we will try to club them and answer on the for either discussion forum or some way. Hello. Yeah, I hope I am connected. Yes. So we want to spread more awareness about open source tools in engineering usage, and this was one of the efforts toward that. So I thank Professor Siddharth Ghosh and Mr. Parth Karya for this wonderful presentation. I thank Institute of Engineers India team for allowing us to use this platform and making all the arrangements so that participants could join online and also on YouTube streaming for live visibility. I also would like to convey our South Gujarat Local Chamber Center Chairman, Dr. K.D. Panchal. He wanted to be here today, but due to his some other commitment, he could not join. But he has conveyed his regard to all of us and for this successful webinar. So thank you all once again for this webinar, joining here, and we will keep doing such more seminars definitely. Thank you.
Thank you.
Thank you.
Okay, Saurabh sir, we can disconnect now.
Nice. Thank you.